Welcome back to EduMoon tutorials. In this video we shall continue our discussion about construction of Moore machine and Mealy machine, and also the conversion of Mealy machine to Moore machine and vice versa. So we shall take an example of designing a Moore machine which gives the output of residue mod 3 for base 2. So the question will be given simply like this one. So designing a Moore machine which will give the output of residue mod 3 for base 2. So from the given question we shall conclude what are the number of states, input symbols and the output symbols. So when we write the set of input symbols, that is sigma, so in the given question it is described as base 2. So the input that we are giving for the Moore machine is a binary number, that is which is base 2. So the input symbols will be 0 and 1, which will form the respective binary number which is an input for the Moore machine that we are designing. Now coming for the output symbols, that is defined using delta. So here it is given as residue mod 3. So the question is like, when you give a binary number, so it will give the output of residue mod 3, that is if you divide that given binary number by 3, so it should give the output of the remainder when we divide that number by 3. So when we divide by number 3, the outputs that we get is, the remainders are 0, 1 and 2. That is, when we divide any number by 3, the possible remainders are 0 when it is exactly divisible by 3, or else 1 or 2. So totally we have 3 remainders. So we conclude our sigma as 0, 1 from the given data as base 2. Therefore we get 2 symbols here, and for the output symbol it is given as mod 3. So delta is equal to 0, 1 and 2. So now we conclude the set of states capital Q, that is equal to Q0, Q1, Q2, because in Moore machine the output is with respect to the states. So since we have 3 outputs, we require definitely at least 3 states. So here we take Q0, Q1, Q2 as 3 states, and we follow the diagram as the following. That is, initial state is Q0 and the output for that Q0 state is 0, and Q1 state has an output 1 and Q2 state has an output 2. Now we follow the sequence of giving the input symbols 0 and 1 for each state. So first of all we do it with Q0. So assuming the first 2 binary numbers, so let us assume that these are the first 2 binary numbers 0, 0, 0 and 0, 0, 1. So for the first number, the output when we divide the remainder, when we divide 0 by 3 is always 0. So when this input sequence is 0, 0, 0 or any number of zeros, we will remain in the same state Q0. Therefore we get a loop over there. Q0 on 0 comes back to Q0, and when it is 0, 0, 1, it is binary input 1, and when we divide with 3 we get again remainder 1. So by this we completed the transitions for Q0 state. Now we take the another next binary number, that is 0, 1, 0, which is equal to 2, and 0, 1, 1, which is equal to 3 here. So now 0, 1, 0 is 2, that is when we divide 2 by 3 we get the remainder 2. So when you start from the initial state, Q0 on 0 goes to Q0, and next symbol is 1, so Q0 on 1 comes to Q1, and again 0. Now that is, we need to give the input transition for Q1 state with the input symbol 0, so which is equal to 2. So the remainder will be 2. So we go from Q1 of 0 to Q, such that we can check that 0, 1, 0 input sequence will generate us to, will take us to state Q2. So the final output will be 2. So 0, 1, 0, starting from Q0 we come back to Q2, so the remainder will be 2. Now finally 0, 1, 1, which is equal to 3. So 0, 1, 1, when you divide 3 by 3, the remainder will be 0. So at the end of the string 0, 1, 1, we need to be in Q0 state so that it gives the output as 0. So already from Q0 on 0 we came back to 0, and Q0 on 1 we went to Q1. So from Q1, if you take a symbol 1, we need to come back to Q0 state, which is generating an output 0 in this way. So here we completed the input transitions for Q1 state also. Later we will see the transition diagram, state diagram, or else what we call as table, transition table, which will show us the inputs and outputs. The next binary number we take is 100 and 101. that is equivalent to decimal 4 and 5. So now the remainder for 100, that is 4, is after you divide 4 by 3, the remainder will be 1. So for 100, after reading the symbols 100, we should be in the state Q1. So you check from the initial state again. Q0 on 1, we go back to Q1. On Q1 at 0, we come back to Q2. So from Q2 on 0, we need to go back to Q1 state so that it gives the remainder as 1. So we have put an input transition from Q2 on 0 to Q1. So therefore 100, you can check that from Q0 on 1 we came to Q1, from Q1 on 0 we came to Q2, and from Q2 on 0 we came back to Q1. So the last output will be 1. So 100 will give us the remainder, or as the output as 1, and 101 is equal to 5. So that is the remainder of dividing 5 by 2 will be 5 by 3 will be equal to 2. So we should be in the Q2 state. So simply we write Q2 on 1 equal to Q2 again. So in this example we completed our construction by all the states having our 2 input symbols. So you can complete the table. So you can understand that we took the first 6 binary numbers from 0 to 5 because there are 3 states and 2 input symbols. So we require at least 6 combinations. So that is from 0 to 5. So you can check now all the states got all the possible input symbols and their combinations. Now if you write the table for this one, the Q1 on 1 goes to Q0. Previously it was miswritten like 0. So it is already, you can correct that. Q1 on 1 goes to Q0. So this is the table which looks like this one. So this is a Moon machine table here. And we check the correctness of the machine using any string. So let us take an example of any string. Let us take a huge number like assuming 41, example of 41. So we take the binary value of 41 is equal to 101001. That is the binary value of 41. And the remainder for 41 when you divide by 3 is, so 3 13s is 39. So the remainder will be 2. So when you process the string 101001, at the final state it should be at Q2. So we check that 101001 from the starting state. You can see that it travels from Q0 1 0 1 0 0 and 1. So we are in the finally at Q2 state. Similarly, you can take any example, any binary value, and you can check the correctness of this machine here. So this is how we designed a Moore machine which outputs residue mod 3 for base 2. Similarly, you can try for other mods like residue mod 4 and base 3 and other examples. Now we try to convert the same machine into a melee machine here. So without erasing this one, I'll complete the conversion of this machine to a melee machine. So the general structure of a melee machine looks like this one, which is written in blue. The melee machine structure is this one. So for each state there will be different outputs. It is not ascend and output like what we have seen in Moore machine here. So each state doesn't having any output in this way. So generally what we do here is we can directly do that method converting from Moore machine to melee machine. Just write the possible states as it is from the given table of Moore machine, that is Q0 on 0 is Q0 and Q0 on 1 is Q1 and so on. We can fill the respective columns here. So we can see we can write the possible next states as it is from the Moore machine. Now coming to the outputs, here in the Moore machine table, Q0 is assigned a output symbol of 0. So from the table, transition table of melee machine, wherever we have Q0, we can write an output 0 there. That is, wherever we have Q0 in the melee machine table, the respective output, that one is 0 here. And whenever we have a Q1 state, the output assigned in melee machine is 1 here for Q1 state. So simply from this table, wherever we have Q1 state, we can simply write 1, the output 1 there. And finally coming to Q2, the output is 2 there for Q2 state. So wherever we have Q2 in the melee machine table, there the output will be 2. So this is how we convert a Moore machine into a Mealy machine directly from the table, and later we can draw the diagram for Mealy machine also. So converting a Moore machine to a Mealy machine is very simple. We'll see in the next video how to convert a Mealy machine back to Moore machine in the next video. Thank you all.